Hello, and welcome to AWS Review, a weekly look at what's happening at AWS and how it may change your business. I am your host, Michael Krause. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co-host, John Affolter. So I'm a lead solution engineer on the AWS specialist team at Salesforce, where I work with potential customers and help them envision the possibilities that AWS enables. So
Welcome, John.
yeah,
So, for people who've watched the stream before, you know that there's a little bit of a change that's happening right now. John and I have worked together for a couple of years now at Charter
yep,
Solutions.
yeah,
And
almost
John
three.
John has moved on to Salesforce.com to help them out as part of how they're interacting with AWS. John, you want to tell us a little bit about what you're going to be doing?
Yeah, so I'm going to be working, with some of Salesforce's largest clients and specializing in the AWS and Salesforce partnership. So, really focusing on building products that have a good developer experience, a good seamless experience from Salesforce into AWS, and I'm really excited because I think that Salesforce does a lot of great things, but being able to partner with AWS really opens up the ability to really provide scalable, real-time solutions that cover a lot of different things. So, it's sad to leave Charter, and I'll definitely miss it, but I know I'll be working with you guys here in the future either way. So,
Yep.
I'm
Well,
excited for the next role.
yep. We're excited to see you continue to grow and learn new things. And you know, as people can see, you're still here with us for AWS Review, and we're looking forward to a continued partnership there.
Yeah, no, and I'm excited to keep this going and grow this. And yeah, I think it'll be something that I think in the end it'll be something I think will everyone will benefit from. And I'm definitely excited to still get to bug you each week, Michael. So.
We always have great conversations. We
Yeah,
always.
absolutely. So before we move into the topic of the day, which is going to be AWS Lambda versus ECS, let's take a quick look at what's been happening at AWS over the last week. So I see that Amazon MSK, which is the managed streaming for Apache Kafka, which Michael, I came into Charter being a big Kafka fanboy. So it is now in a serverless version. So definitely a big step up for them. It automatically provisions and manages the required resources, so you can provide on-demand streaming and storage for all your applications. So you avoid all that provisioning and scaling that you didn't like from Kafka when I talk about it. And it provides up to 200 megabytes per second of write throughput and 400 megabytes a second of read throughput. So that's it also allocates up to 5 megabytes per second of write throughput and 10 megabytes of read throughput per partition. So
That's awesome.
a lot of power behind that. So, Michael, what do you think about the move to serverless? Is this going to be a Kinesis fighter or what?
Well, I think it's always, going to be an option. Kinesis and Kafka both have their strengths and weaknesses. And I've seen companies who have wanted to go to Kafka, but chose Kinesis just because they didn't want to manage the cluster.
Mhm.
And I think this is interesting because it continues to demonstrate Amazon's commitment to taking away the heavy lifting, right?
Yep.
It's probably very rare to find a company who says, our secret sauce in our competitive marketplace is managing Kafka clusters, right? No, it's the data that flows through Kafka that is really where they're bringing value to their customers. So anything that a company like Amazon can do to reduce the amount of work required to manage that cluster, to make that data flow, to analyze that data, just allows organizations to spend less money maintaining things that aren't adding value and focusing their energy and their finances on things that do add value. So I think this is awesome. It's great to see more technologies becoming more automated for end users.
Yeah, no, absolutely. And I don't know enough. I should have researched a little bit before about the pricing comparison between or the managed Kafka versus Kinesis, but I think at the end of the day, it'll just help, alleviate any objections of moving on to AWS in general.
Well, today our topic of the day is focusing on two technologies that do very similar things and asking the
Mhm.
question of which should you use. Maybe this is a good idea for another topic later on, is taking a look at
Yeah,
the streaming
absolutely.
capabilities within AWS and asking that question: when do you use Kinesis? When do you use Kafka?
Yeah, no, absolutely. And yeah, I know you have another update, another more serverless. So
Right. So this is, yeah, kind of on the serverless side. So this is a change in Amazon Redshift. So they've announced now, and just to be clear, this is in preview only at the moment, streaming ingestion for Amazon Redshift. Now, people have streamed data to Redshift in a few different ways in the past, including the use of Kinesis Firehose, which can write directly to Redshift. But it always leveraged a capability that they referred to as micro batching. So what you'd actually do is you'd write your records out to an S3 bucket, and then after you've got a number of records out there, you would make a copy command to Redshift that would then load those records into a table. Amazon Kinesis Firehose would do that behind the scenes for you. If you chose Redshift as a destination, it would literally write those records to S3, and then after a certain batch of records have been written, it would hook into Redshift and execute a copy command. So what they're doing now in preview is they're releasing the ability to connect up to a Kinesis data stream rather than Firehose
Mhm.
and ingest the data stream directly into Redshift. It's just been released. I don't know a lot of the details yet, but there's a great blog article out there. It requires the use of materialized view, which when that materialized view refreshes, it's actually refreshing its data set from the stream and writing it to a local static table within Redshift. So it allows you to skip that whole write to S3, ingest things a little bit faster. And as we were kind of chatting, pre launch of the episode today, this is another step in Amazon's move towards streamlining how we can move data and process data in real time. So I'm very excited about this. I'm a big real-time data guy. I have very strong beliefs that more and more organizations are looking at how to get to real time, reduce that time window between, ingestion when the data gets to you to when you can actually operate upon that data. So I
yeah,
think it's great.
yeah, no, I think it's really big too because you can get the data into Redshift a lot quicker, and then you can start processing the data in Redshift as opposed to somewhere else, and it just a whole nother paradigm shifter as you're moving from near real time to actual real time, and maybe you can use that latency break that you're getting and do some more processing in Redshift as well.
Right. Absolutely. Absolutely. So we should probably move on to the topic of the day.
Yeah.
And today we're going to be looking at AWS Lambda and Amazon Elastic Container Service. And we're going to look at what they are, what the trade offs are, and we're going to do some discussion around best use cases for each. When should you use one? When should you use the other?
Yeah. I guess, starting off with that, Michael, kind of walk us through, what is Lambda and what is ECS and, also with Fargate in mind too.
Right. So, I'll make a couple of assumptions here that people generally know what these things are. So I won't go into
Mhm.
a deep discussion. But Lambda basically allows you to run code in short windows of time, max of 15 minutes, without any infrastructure per se, right? So you don't have to manage any servers, you don't have to manage any containers, any of that stuff. You just make a call, the Lambda runs, and it completes. ECS, on the other hand, is Elastic Container Service. It's Amazon's mechanism to run and scale containerized workloads. So you build up a container image, you can deploy it out to Docker Hub, you can deploy it to Amazon's ECR, their Elastic Container Registry, And then from there, you can bring that image in, spin up a runtime version of it, which we refer to as a container, and scale that container up and down. And that container basically acts like a server, right? In the past, we'd build a box, install the software on it, and run that. And then we moved to things like VMware, where we'd virtualize those boxes. Containers is another level of virtualization you could think of. One of the aspects that's different between the two is kind of the model about how they execute. Containers run in your traditional deployment model where you've got a process that starts and runs, and that process is either waiting for work to be assigned to it, or it's looping through and making calls out to do something, right? So if you're thinking about using a container to back a REST API, it's going to be listening for incoming HTTP connections. And when those connection requests come in, it'll receive them, process it, send a response back. If you're trying to do things asynchronously, you may be having it listening to a queue or a Kafka stream as a consumer, et cetera. But typically, the code in the container has to initiate the process, right? Lambda, on the other hand, is event-driven. So Lambdas, you don't typically, hey, I'm going to run a Lambda and it's going to sit in the background and just run and do stuff. Mm-hmm. Lambdas are event-driven, and AWS tells the Lambda when to run. And there, just about any event available in AWS can be routed to a Lambda for processing. So API gateway, so an inbound REST call to API gateway can be sent to a Lambda. SQS queues sent to a Lambda. Kinesis streams sent to a Lambda. But AWS behind the scenes provides the bridge between those event sources and the Lambdas themselves. So they run very differently. It's very difficult to get a Lambda that just, runs and runs and runs, especially since they have a max of 15-minute window.
Yeah, and that's a good point too, Michael, is that, there's so many different thresholds that you have to think about when you're looking at how you're going to architect your environment. And, I guess when you go to, and you're just in green field, what are some of the things that you look at when you're considering choosing Lambda versus ECS, and what are some things that, each time are kind of a for sure thing you'd go one way or the other, and maybe there's some gray area for both. So
right. Well, if you look at the operating model that I just discussed, that's kind of your first factor you might consider, right? Mm-hmm. Am I building something that I want to be event driven? And more importantly, I want to scale as the events happen, or do I want something that's going to be a kind of a constant running processor? Yep. So if you've got a scenario where you've got a lot of information flowing through a pipe and you want the same process to process it, or if it's real time and you need to process it in order, so it's nice to run it through the same process, containers work really well for that. Mm-hmm. On the other hand, if you've got things that you don't know when something's going to happen, but when it happens, you need to react to it, then Lambda might be a good example of that. One of the obvious ones is if you have long running processes, right? I get a 40 meg video file in and I have to do a whole bunch of processing on it, and it typically takes 40 minutes to do. You can't run that in Lambda. Lambdas are limited to 15 minutes, right? So there are constraints around each that will help guide that. But the other one that you need to consider, and I don't know that people have considered this as well as they maybe need to, is cost. Because the cost of running Lambda and the cost of running Fargate or ECS, there's some pros and cons to each in different situations.
Yeah, and I know, and forgive my background noise, I think the garbage truck's outside, but
it's that day, isn't it?
Yeah, it seems like every day, pretty much. Anytime I have an important call, there's definitely a rumble outside. But, Michael, I know you shared with me the other day, you created kind of a cost analysis, and I thought there's a lot of really interesting kind of thresholds where the cost, really starts to shift from Lambda being cheaper over to Fargate. And yeah, I really thought that was super interesting. And it's definitely something that, not just for this service, but a lot of them, there's a lot of those trade-offs there.
Right. So this is a really a good segue here, because if you take a look at the cost of Lambda, and one thing I want to point out before we dive too in, this cost scale is logarithmic over here. So we're looking at, as we go up, 5, 10, 20, 50, 100, 200. So just keep that in mind. But what I've done here is I've taken a look at the cost of Lambda versus the cost of ECS, and I've done it at different transaction rates. So really slow, one transaction per day, one thing per day happens, one per hour, one per minute. And then I start wrapping it up, 30 per minute, 1 per second, 10 per second, 100 per second, 1,000 per second. And obviously things grow with Lambda as you increase the number. Now, Lambda's cost model is you pay per invocation. So if I've got one event that comes in that I need to process, I pay a certain amount. If I have 2 events come in, I pay twice that amount. 3 events, 3 times. 4 events, 4 times. So the cost of Lambda goes up linearly with the number of executions you have. And when I put the spreadsheet together, there might be a little bit of variance in the numbers I'm going to show you today. I did my best to kind of do as close to an apples to apples comparison in load and things like that. There may be some efficiencies you can gain either spot, but in general, I think you'll find these numbers are pretty close. So Lambda, you start very, very tiny numbers. But when you go to ECS, and here I'm looking at Fargate. So Fargate, for people who aren't familiar, is the serverless version of ECS. Amazon takes care of handling all the servers behind. You can also use what's called EC2-backed ECS, Elastic Container Service, which uses EC2 instances, but you have to manage a cluster of those. And what you'll find is that the costs tend to shift a little bit as you shift a little bit higher on the ECS piece. So this is your Fargate or ECS Fargate costs. So what you'll notice here is up until we get to about 1 per second, I'm kind of flat. And that's because in this scenario, I'm assuming that I can't scale to 0. So that I have to have at least one process running 24 hours a day to be able to handle that ongoing kind of occasional request. So if one request comes per day and I need to handle it right away, I need code running to handle it. But once we start getting to a point where we're scaling, that's when we're having to add more instances of that container and watch that flow up. So now let's compare Lambda and ECS together. So Lambda is the orange, ECS Fargate is the blue, and you can see that, Lambda is much, much less expensive when it's intermittent, 1 per day, 1 per hour, right? And then once we start crossing that 1 per second transaction per second threshold, you see they're tracking pretty well with each other. And in general, it flattens out that Fargate, at least the on-demand pricing for Fargate, runs about 17% higher than Lambda in the comparisons that we're doing here. Now, in general, you might look at that and say, okay, well, in that instance, it doesn't really matter. I could use Fargate, I could use Lambda. It might be a little more expensive for Fargate, but maybe I have more flexibility with Lambda. But Fargate has more pricing models available. So the first thing we can toss in there is a savings plan. So a savings plan allows you to apply a discount for compute by committing to use a certain amount of compute over a year or 3 years. So here we have a same scenario, we're flat for a period of time, but now as we go up, the savings plan has put us in a spot where we're just slightly less expensive than Lambda, about 6% savings. So again, not much. They're still pretty close to each other.
But if you're choosing ECS anyways, you probably have a better idea of what the workloads look like anyways. So then you can really tap into those money savings potentially.
Yeah. Well, and already what we're seeing here is independent of on demand or savings plan. If you're running 1 per minute or less at a transaction rate, Lambda's by far cheaper, right?
Yeah.
Here we're talking less than, we're talking pennies. We're talking $29, right?
Yeah, no, absolutely. At what point, because Lambdas only run 15 minutes, but you could have a few Lambdas go off at once. I guess where is that threshold if you try to break it up into multiple Lambdas at all?
Well, so if you have a Lambda trigger other Lambdas, you're now paying for those other Lambdas as well, and that's going to add a multiplier to your cost.
Mm-hmm.
Because if I have one trigger another and they both run for the same amount of time and use the same level of resources, it's going to be 2x, right?
Yep.
So there are things you need to think through on that. For this one, we kept the model simple. It's a short duration transaction. It could easily be handled by either one the same way. So we're trying to kind of massage out as much, just to do as much of an apples to apples comparison that we can here.
Yep.
Right. Obviously, when you look at your workload, you need to look at other things. There are techniques and things we can use, but this is meant to give you kind of a guiding point.
Yep.
So you can see here at around 1 transaction per second, we start to get to a very similar kind of price point, 55 per month versus 58 per month.
Mm-hmm.
Now, Fargate also has spot instances. And for people who are unfamiliar with spot instances, Amazon makes all these virtual servers and capacity available, but they also have a situation where if people aren't renting the capacity, they've got unused capacity that's making them no money. It's just sitting there.
Yep.
So spot is the way to say, I would like to pay a much lower price to use that unused capacity, but I'm willing to give that capacity up if somebody's willing to pay a higher price for it.
The old bidding wars.
Yeah, bidding wars. But it does create a great way to bring prices down. And a lot of organizations have shifted to a on-demand or savings plan plus spot kind of scaling scenario so that they can get, a commitment of at least a certain level and then leverage spot to get peaks and stuff taken care of at a lower cost. So let's take a look at what happens if I bring spot into the picture. So here, again, same kind of pattern. It's flat for a while, but as soon as we start increasing, you're noticing spot is less than it. And here the logarithmic scale really kind of blurs the lines here because it doesn't look like much, but when you do the math, it's about a 65% savings if we're talking 100% spot over the Lambda cost. And I've got another chart where I've switched the scale to a linear scale. So now you can see the difference. Of course, when I go linear, all these lower numbers just kind of disappear off the chart.
Yeah.
But you can see the difference in price. Now, it's very rare that you're going to get a workload that is 100% spot. So what we kind of determined is when you cross that kind of about 1 to 1.5 transactions per second threshold, pure Fargate spot is much more price effective than Lambda. But when you start looking at a mixed model of on-demand plus spot, especially when applying savings plan, it really starts to get into big savings right around 3 to 5 TPS. So 3 to 5 transactions per second. If your use case allows for it, doing Fargate is much better. So for example, if you're using this as a back end for a REST API, and people call your REST API 30 times a day, go with Lambda. It's going to be much cheaper, right? And it can see API gateway Lambda. It's going to be much cheaper. But if you've got something you're running 50, 100, 200, 500 transactions per second, you're going to save a lot of money going with Fargate or even EC2 backed ECS by mixing spot and on-demand or savings plan type instances together.
Yeah. And I think the important thing too, Michael, is that you are doing it with Fargate. So, this is all the serverless piece too. And I think that's important when you're thinking about just managing that cluster and what that looks like, not just for the application you might be building at the time, but, kind of as you really expand out into and really have a huge microservices environment that's really going to help out in saving time.
Yeah. And I've got numbers looking at the EC2 backed ECS versus Fargate. But what you'll find is that Fargate and EC2 track pretty close to each other with a small percentage difference, right? If you're doing if you're doing on-demand and savings plan, you're looking at EC2 being a little more expensive than Fargate. When you go to Spot, EC2 is actually a little bit less, if I recall right. I might have those backwards,
Yeah.
but they're really close together. So in that scenario, where I've typically seen people go is they go Fargate if Fargate supports it. If Fargate can't support their need, they go to EC2. And a big one there is GPU. So if you're running machine learning models, audio or visual, kind of encoding, transcoding kind of stuff, and you require GPU to speed that up, you need to go with EC2 backed ECS. But now you're going to have to take on a little more monitoring and management of an EC2 cluster behind it. They give you a number of things to help automate, but you still need to do that. Fargate takes care of all that. You just say, here's how much space, much CPU and memory I need for my containers, and Fargate allocates the capability.
Yeah, and just set it and forget it. And I think that's kind of a reoccurring theme that we're seeing just in all of the updates that we're seeing as well, is just set it and forget it, and really, take time to focus on those differentiators. And I'm excited, with the updates. I think it was last week or the week before, of serverless, compute for inference, and really, turning the whole machine learning pipeline to become serverless, because, there's whole entire teams at companies that's all they're doing is just managing that and provisioning. And, it kind of, not to track off of our topic at all, but it really kind of interests me in, how that really shifts the paradigm of what an engineer is going to be within data science, because data science started merging into machine learning. Data engineers started coming into machine learning engineers. And, whereas I really think that we're going to get to a point where you're going to have just a citizen data scientist and somebody that can just work across the industry, and they'll be able to, easily deploy environments really quickly. And it's really it might come back to really understanding the business and understanding the industry.
Well, and this is, now we're wandering a little further off topic, but it's an interesting topic because, we look at the analytics space and the big push towards self-service analytics, right? How do we enable people in the business to do this work and not require IT teams to build it, right? And the cloud, you're seeing go a lot of the same ways, right? How do we minimize the amount of heavy lifting that the IT team has to do to enable a business user to do what they want to do, right? And way in a prior life of mine, I did a lot of work helping companies implement business rules engines. So IBM J Rules, Haley, FICO's Blaze Advisor, all of those types of things. And it was interesting. I did a lot of work with property and casualty insurance companies, and almost invariably, we ended up having a team that was responsible for the heavy core lifting. We had our underwriters and such. And then we've actually built a hybrid team in between that was a combination of people who had some technical capability and a set of underwriters. And we taught this team to write and manage all the rules. So we were pushing that forward into the business and building that capability without them having to understand all the deep messiness of how we deploy a rules engine, how we manage scaling a rules engine. They got to focus on, how do I build rules? How do I dynamically adjust rules? How do I create rules that fire in certain situations and not others? And they were focused on the business logic. And we're seeing that same progression with the cloud.
Yeah, no, absolutely. And I guess to bring it back to the topic, is that, building these microservices environments allows you to, especially if you set it up in the right way where you have the right adapter patterns, then you can have teams that really are focusing on and build those kind of purpose-built teams that are mixed between the business people and the software people and the software folks, start to learn the industry as well. And I guess to close out here, I know we're coming up on time, but, as that keeps evolving, how is that going to influence, versus functions and building things for functions versus, just having a microservice environment? Do you think that might change things around? Or?
Well, I think what you're going to see happen, and to me, interestingly enough, what interests me is not so much the technology piece of it, but the organizational change aspect. Because, the technology is going to continue to move forward. the big question that a lot of organizations happen is as change accelerates, technology change, market change, etc., how can they accelerate and scale? And isolating the work to a bunch of IT people or a bunch of technical people who may not have as much understanding of the business needs as the business people,
Mhm.
that creates a communication gap, that creates a scaling issue, right? You've got some bottlenecking in there that
Yep.
prevents you from scaling. The more we can put capability smartly into the hands of the people who are directly facing the market, the faster an organization can scale and react to competitive situations.
Awesome.
So I think that's where this is going. So we need to wrap this up for today. And we appreciate everybody who tuned in today. Thank you for joining us. We hope you learned something again. If you liked
Yeah.
what you heard, please subscribe to our channel on YouTube. And next week, we will be here again with another wonderful and fun topic. John,
Yeah.
thank you so much for joining.
Yeah. Thanks.
All
See
right.
y'all.
Thank you, everybody. We'll see you all next